Welcome to Chapter 13. We are going to be talking about statistics and probability. It's going to be a really fun chapter. It's one of my favorites that we do in the year. And so let's start with some of the definitions. The first one being what an outcome is, and that is the possible result of an event. The event is a collection of outcomes. So this outcome can be something that actually happened or possibly will happen. So when we're talking about that, it's one. And then event is, let's say we're going to flip a coin 3 times. So when you do something like that, the 3 altogether would be the actual event, the collection of outcomes. Maybe you're going to spin a spinner 2 times. Maybe you're going to do something 10 times. That is the one event, and then the outcomes that you get in those events will be factored in. Favorable outcomes is the specified thing that you want to happen. So in a coin flip, if you pick heads so that you get the ball first, or let's say that you spin a spinner and you have to get either a number 1 or 2 or like a dice, those would be favorable outcomes. And obviously the unfavorable ones would be the opposite. So if you called heads, the unfavorable outcome would be tails. If you need to get a 1 or 2, then the unfavorable outcome would be 3, 4, 5, and 6. Okay? So these are all things that are going to pop up as you do this. So now we're getting to the main thing we're talking about, which probability. It's the measure of the likelihood that some event will occur. So a lot of times when they have contests, they have already figured in the probability ahead of time. Sure, somebody will win, but the probability is usually that you won't. Otherwise, they lose a lot of money. They're selling you a little bit of hope. So the probability of an event is the number of favorable outcomes to the number of possible outcomes. This is important to note because we're going to be dealing with odds, the odds of something happening, which is a little bit different. So be ready for that. So if we are going to say flip a coin, the possibility that you will flip a coin and get heads, that's your favorable outcome. So that's 1. How many possible outcomes are there on a coin? Well, there's 2. What about on a dice? What is the probability that you will roll a 1? Well, it's 1 out of 6 possible outcomes. What if I say, what is a possibility that on a dice you roll a 1 or 2? Well, that's 2 out of 6, or you could reduce that, and you should, to 1 out of 3. You will get either a 1 or 2. Okay? So we just talked about this, and you can go ahead and start filling these in as you remember how to figure probability. In a coin toss, you call heads. How likely is it that you win the coin toss? You have a 1 out of 2 probability, half a chance. So you could do this as 0.5, or you have a 50% chance. Normally we're going to use the fractional form, but I wanted you to note that this probability comes in the form of a fraction. Once we know a fraction, we know a decimal, and we can figure out percentages too. We're going to do that on a cube. What is the probability on a dice, on one die, that you are going to roll an even number? Well, you can either roll a 2, 4, or a 6. So that's 3 choices out of 6, which reduces to 1/2. And then what is the decimal? We just went through that, 0.5 and 50%. You have a 50% chance of doing that. What is the possibility, the probability that you are going to roll a whole number, not a fraction or a decimal? Well, the fraction of that would be you have 6 whole numbers out of 6 possible. So your decimal when you make that into a decimal, it would be 1 or 1.0. And then your percentage, if we move that over, scooch that over to the right, boom, boom, it is a 100% chance when you roll a dice, one die, you're going to get a whole number. What is the possibility that you will roll a 7? Think about that. It's a 6-sided cube, just normal. There is no 7 on it. So your fraction will be 0 out of 7. Your decimal will be 0. You could add cows come home zeros if you want. And so you have a 0% chance of rolling a 7. So what is the chance that you would roll a number less than 3? Well, my possibilities are only that I would roll either a 2 or a 1. So that's 2 possibilities out of 6 total, which is 1/3. Okay, and if we did this, if you remember, this is a common one, and it's going to be a 0.3 repeating. And for your percentage, I would say 33.3%. Okay, you could even add the repeating there. Either way is fine. That's pretty technical right there, the most technical. I'm going to pop up the guided practice that we see in the book, and that way you can see kind of where your assignment is going. This one isn't too difficult, but you got to make sure you're looking at the right information. So you have 3 quarters in your pocket and only one is a state quarter. If you randomly choose a quarter from your pocket, what is the probability it will be the state quarter? So if there's 3 quarters in your pocket and only one is the state quarter, you have a 1 in 3 chance that you will get it. You roll a number greater than 3 on a number cube. So what are our choices? 4, 5, and 6. Doesn't include 3 because it has to be greater than 3. So that's 3 and 6, and that would be 1/2. So what is the possibility that you choose a pair of white socks from a drawer containing 4 pairs of black socks, 2 pairs of brown socks, and 7 pairs of white socks? We are going to assume that whoever did the laundry bundled them together, so they come out as a pair. So first of all, we need to see how many total pairs of socks we have. So we have 4 plus 2, which is 6, plus 7, so there are 13 pairs of socks, and 7 of them are white socks. So you have a 7 in 13 chance of getting white socks. That's better than half a chance. All right, so this chapter does have a couple more concepts that we need to talk about. First of all, are complementary events. These are events that have no outcomes in common, but when they're added together, they contain all of the outcomes. So it's easier for me to give you an example of a complementary event. This complements what you actually want to have happen. So if I want the complement to rolling a 1, the complement would include rolling a 2, 3, 4, 5, or 6. So the favorable outcome would be you have a 1 out of 6 chance of rolling that 1. So then you have the complement, which is a 5 out of 6 chance of not rolling a 1, because it's either 2, 3, 4, 5, or 6. Notice if you add this 1/6 plus 5/6, that includes all of the chances. So in a coin flip, what are the favorable outcomes if you chose heads? Well, you have a 1 in 2 chance of rolling or of flipping a head. And then the complement, this is a coin, and I'm going to put heads. In a coin flip, the complement, this should be complement, you also have a 1 in 2 chance of not flipping a head. And when you add 1/2 plus 1/2, 2 out of 2, which equals 1. Okay, so the complement is the opposite of what you want to have happen. So sometimes we see that our odds are 1 in 6 and we think, oh, that's good, I have a chance. But then when you look at the complement or the opposite, you say, well, I have a 5 in 6 chance of not winning. So that's a good thing to know. This is both on your quiz. This is also on the test. So a lot of kids will forget this. So if you want to put a star, if you want to put little bubbles around it so you don't forget what a complementary event is. Okay, so we're going to find the probability in this spinner of spinning a vowel. So I see A and E, and there's 1, 2, 3, 4, 5. So there is a 2 out of 5 chance of spinning a vowel. What is the complement to that? Well, I would either spin A, B, or I would either spin B, C, or D. That's a 3 in 5. And when it says describe the complement, it would be spinning B, C, or D. You can list them, or you can say, or not a vowel, or you could say spinning a consonant. I would accept all of those answers on a test. When it says describe the complement, put it into words. And then when you put it into numbers, that's its probability, 3 out of 5. 2/5 plus 3/5 is 5/5. So here we need to see how many spins out of 50 would it be likely that you had consonants. So this is my probability that I would have a consonant. So what I would do is I would multiply 50 by 3/5. Okay? So when we multiply 50 by 3/5, we will see which way I want to do this. I'll go ahead and reduce it. We'll do 1, and 5 goes into here 10 times. So 30 out of the 50, so this vinculum means out of, 30 out of 50 of them will be consonants in the spinning. Okay? So what do you do when it says this is the probability of one event? You multiply it times the number of times you're going to do it. So if we were going to spin this 100 times, we would do 100 times 3/5. If we wanted to say, okay, what is predict the number of spins that you would spin a vowel? Well, then it would be 50 times 2/5. Okay? So if you randomly choose a marble from a bag of 2 blue, 3 yellow, 4 green, and 3 red marbles, what is the probability you will not choose a blue marble? First thing we need to do is add it all up. So 2 plus 3 is 5, plus 4 is 9, and then plus 3 is 12. So we know that there's 12 marbles in the bag. Okay? We also know that we don't choose a blue, so any other one but blue. So let's add yellow, green, and red. Notice the not. That's where a lot of kids mess up on these. So 2 plus 3 is 5, plus 4 is 9, or I'm sorry, 3 plus 4 is 7, plus 3 is 10. I already figured the bottom number, so we didn't need that. So we have a 10 in 12 chance, and when we reduce that by 2, we have a 5 in 6 chance of not choosing blue. So it's important that you label, and that's going to be important on the quiz. So we're going to go back to the spinner. Can you try to predict the number of spins out of 50 that will be vowels? So do you remember what I told you to do? If you want to try it yourself, pause me. Otherwise, I will do it